Today we will be talking about alternating current. Relation between current and voltage, and in case of pure resistance, capacitance and inductance, we will study what is the current value as well as the power with all phasor diagram. We'll also look into the combination of RC, CR and LCR in series as well as parallel, and understand the types of LCR circuits, filters, the usage of transformer and all. So before all these topics, let's understand the verses of DC and AC. So Thomas Edison pushed for the development of DC power network, and Nikola Tesla, who is a physicist, inventor of American country, was instrumental in developing AC networks. And George Westinghouse backed Tesla's development of an AC power network. So Edison was a brute force experimenter, but was no mathematician. And AC cannot be understood or exploited without a substantial understanding of mathematics and mathematical physics, which Nikola Tesla possessed. So what is AC? Let's understand an alternating current. So to keep oscillations going, we need to drive the circuit with an external EMF that produces a current that goes back and forth. There are two frequencies involved: omega, at which the circuit which would oscillate naturally, and the other one is omega d, the driving force at which we drive the oscillation. However, the natural oscillation usually dies off quickly, exponentially with time. Therefore, in the long run, circuits actually oscillates with the frequency at which they are driven. You can see that picture over there. This is true for the gentleman trying to make the lady swing back and forth in the picture too. Alternating voltage and alternating current vary continuously in magnitude and reverse in polarity. And one cycle includes the variation between two successive points having the same value and varying in the same direction. So how you define an AC? The direction of the current in a resistor or in any other elements changes alternately, then the current is called alternating current. In the previous class, we understood what is DC. We have defined simply saying that unidirectional current. Direct current can be defined as it is a unidirectional current, whereas the AC, the direction of current, when it changes alternately, then we can say it as an alternating current. Or the AC which varies sinusoidally with respect to a time. So such currents can be defined as an alternating current. Now say this, a loop of wire spinning in a constant, this is a constant varying magnetic field. A loop of wire spinning in a constant magnetic field will have an induced EMF that oscillates with time. So this is a spring which is spinning on this particular magnetic field. So as long as this particular loop wire is spinning, we can see that there is an induced EMF set up in this particular loop, and we can see that the current is flowing in this particular loop. So it can be an AC generator. So ACs are very easy to generate They are also easy to amplify and decrease in voltage. This in turn makes them easy to send in distribution grids like the ones that power our houses. Because the interplay of AC and oscillating circuits can be quite complex, we will start by step studying how currents and voltage respond in various simple circuits to AC. The voltage and current in AC circuit both average to zero, making the average useless in describing their behavior. We use instead the root mean square. We square the value, find the mean value, and then the take square root. So often electrical signals look like sines, sinusoidals, or sines or cosines, we can say that. And we normally use an AC with an any appliances at home as well as commercial or industrial anyway. Sine and cosine are identical. If you see this graph, this is an alternating signal. So the one which is with a blue color is a sinusoidal wave. We can say that this is a sine wave. And the one which is with a green, this we can say that it is a cosine. So these two, are identical, but related with a phase shift. Cosine wave is advanced by 90 degree. If you see, this is a 90 degree, this is 180, this is 270, and this is 360. In the next slide, we will see the radians and angles for that. So here you can see that the cosine wave is advanced by 90 degree compared to the sine wave. So what is cosine? So cos omega t is nothing but sine omega t plus half into pi. So pi by 2. It means the cos is in, we can say it is leading by 90 degree. And what is the frequency? When we say that the particle is in its simple harmonic motion, or when we say that the particle is oscillating, then the frequency would be there. So frequency is nothing but 1 by t, and angular frequency, angular speed, we can say that it is nothing but omega, which is equal to 2 pi f. And this is basically a symbol for an alternating current. And we can give that V is equal to V max sin omega t, or V is equal to V max cos omega t. We will study now into the next slide what is V max and what is omega, what is f, what is all these elements, all these variables. Now the amplitude, the maximum distance traveled by a particle we define as an amplitude. So there are two ways to describe the amplitude. Maximum voltage is an overstatement and average voltage is a zero. So root mean square voltage is probably the best way. Del V square, find the average value, then take square root, we can get the value of root mean square. Now if you see this, this is the root mean square, which is nothing but under root of an average value or maximum value. So under root of V max. And we know as per the second previous slide, V is equal to V max into sin omega t or cos omega t. So if we consider V is equal to V max sin omega t, so this comes like V square max into sin square omega t. So sin square omega t, so this comes 1, sin omega t, it comes 1. So this is half because we have converted into this. So half del V square max, or we can say if you remove this particular RMS is equal to, so this comes like del V max divided by root 2. So this is how the definition of RMS is equal to V maximum by root 2. Similarly, IRMS is equal to I max by root 2. As we understood, the amplitude is to determine the graphically measure the peak of the wave. So this we say that this is the maximum value, the peak value. So this is labeled as an amplitude, and frequency is nothing but 1 by t, and the angular frequency omega is equal to 2 pi f. And the phase shift phi is how much it is shifted earlier or later compared to the basic sine wave, whether it is a leading or whether it's lagging. So that angle will give the phase difference between the two variables or components, current and voltage. So in this slide, the goal is we will be giving this particular AC, feeding this particular AC source to an arbitrary circuit. To individually the resistor components, capacitor components, inductor, or the combination of any of these two or three components. And we will assume the voltage as voltage V is equal to V max into sine omega t, whereas the current as a function I is equal to I max sine omega t minus phi. So this is the value of current which we will be seeing with the function of I is equal to I max sine omega t minus phi. And here whatever the voltage we are taking with having a zero phase shift. So for both these components, we will take angular frequency as omega is same, and we still need to find out what is the difference between now with these two. This is the amplitude variations as well as the phase angle, because both are sinusoidal. Only differing in what? Only differing in its amplitude and the phase angle. So we will take I is equal to I max sine omega t minus phi, where we have to find the value of I max and the phase angle. We will also find out the power value. Power is nothing but the product of voltage into current. So generally, maximum current will be proportional to the maximum voltage, and we can say that Z is equal to, as per the Ohm's law, V is equal to IR. So R will be equal to V by I. So Z is nothing but it is V by I, or I max will be equal to del V max by Z. Z is here an impedance. And next into the slide, all calculations are done in radians, because degrees are very commonly used. So as per the formula, like if you take a current value as an I is equal to I max sine omega t minus phi, this can be written as I max into sine omega is nothing but 2 pi f. So we have just substituted the value of omega as 2 pi f t minus phi. So this comes I is equal to I max sine 2 pi, this phi is an 80-degree angle, so this comes 360-degree ft minus phi. If you see this, angular measure and radian measure. See, the cycle of voltage corresponds to rotation of the loop around a circle. So parts of the cycle are described in angles. These are the angles. These are the angles. The radian is an angle equivalent to 57.3 degree. A radian is the angular part of the circle that includes an r equal to the radius r of the circle. As a circle circumference equals is 2 pi r, so one cycle equals 2 pi radians. Here in this particular table, you can see that we have, this is an angular measurement and this is a radian equivalent. So if the angular measurement is 0 degree, it means there is a 0 radians. 360 degree is nothing but in the form of radian is 2 pi, as 2 into pi is nothing but 180. So 2 into 180 will give the 360 degree angle. And if this angular in degrees are 180 degree, so this comes like half into 2 pi, so this comes pi radians. And if the angle is 90 degree, it is called as in pi by 2 radians. And if it is a 270 degree, like 180 plus 90, so 180 plus 90 is nothing but pi by pi plus pi by 2, so this comes like 3 pi by 2. So this is the basic difference between angular measure and angular radian measure. So you can see this is a sinusoidal wave, a waveform which is 2 and 4 from its mean position. This is an amplitude, a maximum or peak length we can say. And see here, this is a 0 degree, which is a 0 radian, 90 degree, pi by 2 radians, 180 degree, pi radians. This is 270 degree, 3 pi by 2 radians, and this is, we can say that it's a complete cycle, which is nothing but 360 degree is of 2 pi radians. So one complete revolution of the loop around the circle is a cycle. And the half cycle of revolution is called as an alternation. These are the basic terminology. Uh, we have seen like waveform, cycle and time period, frequency and angular frequency, amplitude, phase and phase difference, peak and peak to peak, instantaneous value, average value, root mean square, form and peak factors. So let's understand one by one how we will define as a waveform. A waveform is a graph in which the instantaneous value of any quantity is plotted against time. Cycle, one complete cycle of positive and negative values of an alternating quantity is termed as a cycle, isn't it? So what is time period? Time taken for one complete cycle is called as a time period. And how we will say cycle? So one complete set of positive and negative. So one positive and one negative will give one complete cycle. And the time taken to complete that one particular cycle, it's called as a time period. How you will define frequency? Frequency is nothing but number of oscillations per second is defined as a frequency. And angular frequency is defined as the number of radians covered in 1 second. That is the angle covered by rotating coil. And the unit for the angular frequency is nothing but radian per second. You cannot write the for this particular angular frequency, the unit will be radian per second. And how you will define time period? Time period we have already defined. Amplitude. Amplitude is nothing but the amplitude of a sine wave is the maximum vertical distance reached in either direction from the center line of the wave. So from the mean position, the maximum distance of the peak distance, either of the direction can be called as an amplitude. What is phase? The phase of an alternating quantity is the time that has elapsed since the quantity has last passed through the zero of the reference. And when two alternating quantities of the same frequency having 0 points, they are said to have a phase difference. The angle between the 0 points is the angle of phase difference. Like we will be saying, what is the phase difference between voltage and current in respect to of the resistors or inductors or capacitors individually if you apply an AC current to any of these components. Peak value, we can define peak value is the maximum value either positive or negative that is waveform attains. Peak values can be expressed for voltage or current and as well as for the power. Power is nothing but product of voltage and current. And what is peak to peak? Peak to peak is the difference between the maximum positive and the maximum negative amplitudes of the wave. So if there is no direct current component in an alternating current wave, then the peak to peak amplitude is twice the peak amplitude. So whatever the value of amplitude we will get it. So if you multiply by 2, so that will be the peak to peak value. Instantaneous value. This is the value or voltage of current of a wave at any particular instant, often chosen to coincide with some other event. So for an example, the instantaneous value of a sine wave, 1/4 of the wave through the cycle will be equal to the peak value. And how you will define an average value? The average of an alternating quantity is defined as the arithmetic mean of all the values over one complete cycle. So for all different instantaneous values, whatever we will get it, if you make an average, then that is called as an, for one complete cycle, that is called as an average value. And we have already seen the root mean square. Value of the set of values is the square root of the arithmetic mean of the squares of the values. or the square of the function that defines the continuous waveform. And the form factor is defined as the ratio of RMS value to the average value. It's called as a form factor, which will not have any unit. And the peak factors, or this can be called as in crust factors. So it is defined as the ratio of maximum value to the RMS value of given alternating quantity. So that's are all the terminology where we'll be using into the next slide. So here you can see that the difference between peak and amplitude. So very clearly they have shown that this is voltage peak to peak, and this is an amplitude and peak value. And you can say that this is peak to peak for so we can see that this is not zero. This the slide this should be up to here only. So this will give complete peak to peak value. Let's define exactly the average value now. So the average of an alternating quantity is defined as the arithmetic mean of all the values over one complete cycle. This is what we have defined. So for each degree, each angle, if you see the voltage and this is a graphical method, and you will have the analytical method. So here you can see that this is how it comes, like equally mid ordinates, and average is calculated as sum of all the mid ordinates divided by number of mid ordinates. So if you can calculate, the number of mid ordinates are 10, and for each equally divided mid ordinates, whatever the voltage value you have, like 6.2 voltage, then 11.8, 16.2, all these values up to the 0. This is the 0th value. So from V1 to V12, whatever the values we have, we just substituted here, made the sum, and mathematically V average is equal to 12.64 volts. So this is the value for the positive half of sine, which is nothing but 180-degree angle, or we can say that it is pi radians. So if you want to calculate for the sine wave, the average value can be taken mathematically by taking the approximation of the area under the curve at various intervals to the distance or length of the base, and this can be done using triangles or rectangles as shown in figure. So you can see here. So areas under curve, we have taken this. Now how you will calculate what will be the area for this? So area will be, if the displacement is from 0 to pi, so here from 0 to pi, so the limit comes like integration of 0 to pi, V peak, this is a V peak, voltage peak, into sine omega t into dt. So average value will be equal to what? 1 upon pi into 0 to pi Vp sine theta dt. So this is an omega, and this angle we have taken as in pi, so this comes into this form. Or we can say, if you integrate the sine theta, it is nothing but minus cos theta. So this comes like Vp by pi into minus cos theta, and limit of integration will be 0 to pi. So if you substitute 2 Vp by pi, and if you substitute the value of pi, so you'll get it as 0.63 into V peak. So V average is equal to 0.63 V peak. This is how, for the peak voltage of 20 voltage, so this comes like average V peak should be equal to what? Should be equal to V peak into 0.637, and V peak we say that this is for the 20 voltage. For the peak voltage of 20, we will have 20 into 0.63, so it comes like 12.73 volts. Similarly, to find out the RMS, RMS is nothing but it's a value of the value is a square root of the mean value of the squared function of the instantaneous value, and the symbol for this is VRMS or IRMS. So we can have the graphical and analytical method. So see again here, this is equally spaced mid ordinates. V peak is 20 voltage, and this is 180 degree, and we have taken one positive half sine wave. So with this comes VRMS is equal to sum of mid ordinates. This is of voltages square of this divided by number of mid ordinates. So if you square each value V1, V2, V3, V4, V5 and all up to V12, these are the values what we have taken, and we need to square it and then sum up divided by number of mid ordinates. Here is 10. So this comes like, you know, under root of 200, and this is nothing but 14.14 voltage. This is generally for this particular given values, and analytical method for finding of RMS value of sine wave. So this is how it is calculated. A periodic sinusoidal voltage is constant and can be defined as, we have taken as V is equal to V max into cos omega t with a period of capital T. Then we can calculate the root mean square value of sinusoidal wave as, root mean square is nothing but what we have studied, like it is under root of V square, isn't it? So under root of V square is nothing but, this comes like 1 by t integration of 0 to t V max square into cos square omega t dt. So if you integrate in the form of sine and with the limits to 0 to pi, 0 to 2 pi or capital T, then VRMS it comes like under root of V max square by 2t into small t plus 1 by 2 pi 2 omega into sine 2 omega t with the limits of 0 to t. So after mathematical calculations, VRMS can be written as V max by under root 2. And under root 2 is 1 by under root 2. If you calculate, it is nothing but 0.70. So VRMS normally is nothing but 0.707 into V max. So for peak voltage of the waveform as 20 volts, then what is VRMS? VRMS should be equal to V peak into 0.7071. So that comes like 20 into this, and this comes like 14.14 voltage. This is a comparison between average value and the RMS value. So the definition for the average value is, the average of an alternating quantity is defined as the arithmetic mean of all the values over one complete cycle. Whereas RMS value is the square root of the mean or average value of the squared function of instantaneous value. And this is defined as for the voltage V average or I average, and this is VRMS or IRMS. And the formula for this V average is 1 by t integration of 0 to t dt dt. Similarly for the current, this one. And for VRMS is equal to under root of 1 upon capital T with the limits 0 to t V square dt. The property is, for average value is, average value of a periodic waveform over complete cycle is 0. And for symmetric periodic waveforms, average is calculated for half cycle only. RMS value can be calculated conveniently even for the periodic waveform, because this doesn't come with a 0 value. Once again, we can see that this is the peak value, the maximum distance from its 0 or mean position. So this we can say that V peak or V max related to 0, this is a 0 value. This is an RMS value. This slight dotted line is an RMS, which is nothing but V peak into 0.707. And what is the average? Average value is V average is equal to V peak into 0.637. And this is a center line. This we can say that peak to peak value. Complete distance on this particular positive direction, and this is a negative direction. So we can say that this is V peak to peak. And this is periodic time, where we can say that one complete oscillation from this point to this point. So this is a periodic time capital T, and obvious frequency will be reciprocal of periodic time, so it is 1 by t. Now for different waveforms, we can understand for a different wave type, we can understand what is the waveform, what it is, what it have the mean value, uh, factor, wave factor, RMS value, and crest factor. So this is a sinusoidal wave for an first example. So mean value is equal to 0.637 we have calculated, and this is waveform or factor is 1.11, and RMS is 0.707, and crest factor is 1.414. This all we have calculated for sine. So half wave, the rectifier, when we consider in a half wave rectifier, which is having only one diode, so in that the output will be in this form. This is called in half wave waveform. For this, the mean value is 0.318, waveform is 1.57, RMS is 0.5, and crest factor is 2. And if you take the rectification for the two diodes or the bridge wave diodes, so this is the output of the bridge wave diode, bridge wave rectifier or full wave rectifier in the sinusoidal form. For this, the mean value is 0.637. As please look into this particular sine wave, this value and full wave values will be same. Waveform is 1.11 and RMS value is 0.707 and crest factor is 1.414. If you take the triangular wave, this is a triangular wave, mean value is 0.5, waveform is 1.155, RMS is 0.577 and crest factor is 1.732. For the last square wave, if you take the square nature, for this particular square nature waveform, the mean value is 1, mean form is 1, RMS value is 1, and crest factor is 1. Now let's understand phase factor or phasor diagram. To simplify the analysis of AC circuits, a graphical constructor called a phasor diagram can be used. Now for the next components which will be applying an AC circuit, AC current, with respect to the phasor diagram only we will take the output without the derivation and all. A phasor is a vector whose length is proportional to the maximum value of the variable it represents. The vector rotates clockwise to an angular speed equal to the angular frequency associated with the variable. It is counterclockwise. So now you can see that this we have taken as an V max sin omega t, and this the blue is for represents the current value, the gray shade represents the voltage value. Okay, so this is I max sin omega t and this is V max sin omega t. So this is with respect to I max is this value, this is I max, and up to here is a V max, and this is a into a counterclockwise, and this is an angle which is nothing but theta represented as omega t. The projection of the phasor onto the vertical axis represents the instantaneous value of the quantity it represents. A phasor is like a graph. An alternating voltage can be presented in different representations. One graphical representation is using rectangular coordinates. The voltage is on the vertical axis, time is on horizontal axis. The phase space in which the phasor is drawn is similar to the polar coordinate graph paper. Like the radial coordinate represents the amplitude of the voltage, the angular coordinate is the phase angle, the vertical axis coordinate of the tip of the phasor represents the instantaneous value of the voltage, and the horizontal coordinate does not represent anything. Alternating currents can also be represented by phasors. Now let's say steady state analysis of